Okay, Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is to respond to some questions that I received on Facebook from someone from Iraq that asked some question on statics. So it is quite interesting how people find other people on social media and all this. Anyway, so there are several questions with regard to equilibrium problem. In fact, there's 5 questions. So before we go into any of the specific question, so this is my first comment, right? So in any equilibrium problem, the first thing that you have to be clear is to answer any equilibrium problem, the step is basically this. One is to draw the free body diagram. That is actually a must, because this free body diagram is what is the foundation of what comes next, which is the equation of equilibrium, right? So the free body diagram is what define what forces are there and the direction, and then from there we can write the equation of equilibrium, and then of course we solve. This is almost purely mathematics, right? So that's the thing that you have to understand first, that if you cannot establish the free body diagram, then in terms of engineering that's a problem, right? Because any equation that you come up after that should be based on the free body diagram. Alright, so there are 5 questions, so I'll try to address one by one. So the first question, okay, the diagram is something like this. I'm not sure if this is clear because the marker at this house is already at the end of its life. Okay, so because of the current restriction of movement, I'm doing this at my house, so we are lack of tools and equipment because I didn't bring many of my tools from office. Alright, so this is the first question, right? So the diagram is as such. We have 3 pulleys, 1 pulley, 2 pulley and 3 pulley, and then we have the cable, and then we have the weight. And then the question asks what determine the force P, determine this force P needed to hold 60 pound weight in equilibrium, right? So I find this interesting because so far those who have asked me from either in YouTube or also on Facebook, for whatever reason, the question they have always is in US metric, not metric, meaning US system. Is it US system or UK system? Using pound, inches, etc. Right? So because we are used for myself, I am the SI unit, right? Meter, kilogram, Newton, etc. But regardless, so what is this force in order to maintain this weight in equilibrium? Right, so that's the first thing. So first thing, understand the question and understand what the question wants, what it gives and what it wants. So you have to understand this is pulley, pulley and pulley, weight, and then this is a cable, and from this diagram, this actually, okay, continue on. Of course, working from home, have the babies, etc. Right? Anyway, so again the question is, okay, I'm looking back at the question. So what is the value of P, the force needed to maintain this weight in equilibrium? So several things. This is the force, this is the weight, pulley, pulley and pulley. So from the diagram we should understand that this is the same cable throughout, right? This one, this one, this one, this one. And when you have the same cable, along the cable the tension should be the same, meaning that if this is force P, so the force along this cable should be also P, right? So from there, when we draw the free body diagram, we can have three different free body diagram actually, if you want to draw in total, right? So for example, this pulley here, if you want to draw it, you have force attached there, and then you have the two force, which is P and P, right? Because it's the same cable. Similarly here, if you have this force here, you have P and P here as well, right? And if you draw the pulley here down here, right? So here is P corresponding to this one. Here is also P corresponding to this one. Here is also P corresponding to this one. And then the weight down here is 60 pound or 60 Newton, depending on whatever unit that you have. Let's say that the value is 60 in terms of weight. So if you have drawn the free body diagram, then it makes it easier to solve, because after this we know that we can just solve here, because what we want is P in the end. So this is P, and then this is the value given. So if you do summation of Fy equal to 0 for this free body diagram, we're taking upward as positive. Can you see the color here? So this will make this one P plus P minus 60 equal to 0, and P just equal to 20 pound or Newton or whatever value that is unit wise, right? So it's quite straightforward. Normally, if you have question that involve pulley, especially if everything is vertical like this, it should be quite easy as long as you can establish the free body diagram. So remember that, make sure you understand how to get the free body diagram in the first place, and then equation equilibrium, you just select which free body diagram that can give you the solution. In this case, this one, right? Okay, that's the first question that I was given by this comment or this message. So going to the second question. Determine the normal force that the 100-pound plate A exert on the 30-pound plate B, right? Because some of this is not clear, because it's on message on Facebook and it's quite small in the pixel. But anyway, I believe that is the question. So hopefully you can still hear the voice despite all the noise. Alright, so we have a plate there, and then we have another plate here, and then we have a cable to a pulley to a cable here, and then cable to a pulley, cable here, basically something like that. And that's the dimension given. So this is to the, like that, right? I cannot see clearly the dimension given, but this is A, this is B. What is this? 1 and 4, I think. So I cannot see the number clearly, but I assume it's 1, 1 and 4, the dimension. So it says, the question again, determine the normal force, the normal force that plate A, which is 100 pound. So this is 100 pound plate A, and then 30 pound plate B. So this is 30 pound plate B. So what is the normal force? Normal force meaning that if you separate these two, if you separate the two plates, it exerts, there's a normal force from one to another, right? Hopefully you can see because there's some glare because of the lighting, but anyway, so there's a normal force here, normal force there. So what is that normal force? That's the question. Determine the normal force, right? And it already gives you the weight. So this weight here is 100. This weight here is 30, right? And also you have the force here to the cable, 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 right? And given that, because it is symmetric in terms of the question, it is symmetric and the distance is the same, so for this to balance, and of course normally when you give plate, this is homogeneous material, so the weight is at the middle, the force covered by this part and this part should be the same, right? Because it is balanced. So in that case, if we consider this is tension and tension, it should be tension and tension as well, right? Okay. So in this case, you have actually two free body diagram, this free body diagram and this free body diagram, right? So I'm sorry, the drawing is quite close to one another, so if I'm going to make it more clear, I take it further apart, so it will be something like this. This is normal due to this normal, and then this going down is 100, and then you have T and T, right? So from there you can use equation of equilibrium for this one and also this one, right? How many unknown we have? So actually one unknown is N, one unknown is T. You have two unknowns, so you actually have two equations you have to solve simultaneously to solve for two unknown, and you have one equation here, one equation here from equation of equilibrium. This one, if you do summation of Fy equal to 0, taking upward as positive, you have T plus N minus 100 equal to 0. And for this one, if you do summation of Fy equal to 0, okay, all the markers are running out of ink. So this one become T plus T minus N minus the T equal to 0, right? So I believe you know how to solve simultaneous equation. So you have T and N here, T and N here, two equation, two unknown, you can solve simultaneously to get what is N and what is T. And the question asks for the normal reaction, so the answer should be N, right? So hope that answered that question. So that's question number 2. All are using these steps, right? Question number 3. In each case, determine the force P required to maintain equilibrium. The block weight is 100 pounds. Okay, in this case, it is quite interesting because there's 3 different diagrams given. If you can see the 3 different diagrams given with the pulleys, and the weight is the same. You have to find what is force P in each case. But this question is rather simple and straightforward if you understand the question before this, because when it involves pulley, it can be very, very easy if you draw the free body diagram, right? So let's draw the question first. So the first diagram is you have weight here, and then unfortunately we have limited resource of whiteboard marker. I have to buy, maybe if we continue with things like this. Okay. Okay, so sorry for the pulley being elliptical because this issue is space there, but that's basically how the diagram is. Okay, so in this case, do you think this question is easy or difficult? We need to find P if this one is 100 pound. This is rather easy if you understand what we have discussed earlier, right? Because if you draw, okay, let's draw this one, free body diagram of this pulley here, right? We have 100 pound here, we have force here, and force here, right? Okay. However, it may be a bit more challenging because we have several different force involved, right? Sorry, this small one is here, where you have this one and these two force, and then on top here you have this one where this force here, force here, force here, force above, and then the big one here, force, 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 force upward, right? Hopefully you can see through the glare. Now, this is P, right? This is P and it goes here, right? So this is P as well, and it goes here, meaning this is P as well, and it goes here, meaning this is P as well, and it goes here, meaning this is P as well, it goes here, which means this is P as well, goes here, meaning P as well, goes here, meaning this P as well, goes here, meaning this P as well. Okay, that's the first thing you have to note. If you just go through the cable, and okay, this is P until end, right? And then you have a different force, which is this one. Let's say this is T, meaning this one is T. And then you have another one, which is there another color? This one. Sorry, this one, right? Let's say this is F, and this is F, right? Whatever label you want to use, but just use whatever label you want, right? So based on this, okay, so here, because we just focus on what we need, right? From here, right, this free body diagram, from summation of Fy equal to 0, right, you can get that 2P equal to F, right? This is, I'm skipping steps, but you draw is P plus P minus F equal to 0, so 2P equal to F. So meaning that, or F equal to P over 2, right? So if you know this F, you can put this one, so you can solve actually resolving, if you do summation Fy here, it's basically P plus F plus P minus 100 to 0. But F is P over 2, right? So P plus P over 2 plus P minus 100 to 0. So from here you can solve P equal to something, right? And that's the question, what the question 1, P. So you get the answer already, right? So question involving pulley, do not be intimidated by the diagram because it's quite easy normally, as long as you can draw the free body diagram properly, right? So that's number 1. So we have another drawing. Okay, this is easier. I'm not sure if I can cover all the questions before all the ink is running out, and I'm actually using all the kids stuff, the children's stuff. Alright. So we have the weight here going to there's a pulley here, so going there, and then another pulley there, and then P, and then there. Right? So if this is 100 pound, okay, by looking at it, I think you should know by now that is much more simpler, because you only have two free body diagram. If you draw this one is 100 pound, this is P, this is the same cable going here, so this is P as well, and then of course same cable, meaning this is P as well. So from here you can know, you know straight away you can solve this one, right? By summation of Fy equal to 0, P plus P minus 100 equal to 0, P is 33.3 basically, right? So that's question number 2, meaning the diagram number 2 for that one. We'll go for another diagram, and because my battery is also dying for my camera, so I'm rushing. So this one is, we have a weight to a certain pulley here. Oh. This one, is this a pulley or something? I'm not sure what it is, but I assume it is a pulley because it's not clear. Okay, let's take the problem as such. So again, just detect where is the force. So this is the same cable going here, right? So if you draw free body diagram of that one, of this one, you have P, you have P, you have P, right? And then you have this cable here going down. Let's use T. And then you have this pulley here, which means this is T here, going here, and then this is T, going here, this is T as well, and then going here and going here, so this is T as well, and then this is 100 pound. Right, so straight away from here, summation of Fy equal to 0, you can see that T plus T minus 100 equal to 0, you can get what is T, and from here is P plus P minus T equal to 0, when you know T is, in this case, 33.33, for example, or 100 over 3, plug in here, you can solve for P. Right, so again, I think if you have done enough exercises, you will see that pulley question is normally quite easy. Okay, what else? Determine the horizontal and vertical component of reaction at E and E. So okay, this is a different question. So this is truss and frame, for example, right? So okay, we'll continue with this one. Okay, in terms of the question, this is basically the drawing of the truss. However, I cannot make out what is actually the numbers. I'm not sure if you can, because it's quite blurred and pixelated. Because this message is from Facebook, so you cannot zoom in, unfortunately. But fundamentally, okay, so we'll just answer fundamentally without, I cannot help with the actual numbers, but you have the numbers, right? So actually all of this distance is given. All of this distance is given, right? And then all of these forces given. Let's say this is F1, F2, F3. You have all the numbers there, right? And all the dimensions there. So the question says, determine the horizontal and vertical component of reaction at A and E, right? So you have to determine what is the horizontal and vertical component here and here, right? Now, meaning that, because this is pin and pin, right? So if you draw the free body diagram, if I draw the whole thing, let's say, the whole thing as a structure, right? So basically, when you have a pin support, you have X and Y, X and Y, right? Normally that is the case. Okay. However, because I'm not sure which chapter this is from, but however, because if you understand that, if you have learned already about two force member, you should be able to detect that this actually is two force member. Okay. On two force member, I have covered specifically, I think, on my lecture on the respective chapter. So if you want to understand what is about two force member, go to that lecture. Explain it, right? But what it means is that, because when you have two force member, then the reaction here will not have this component, or the X component will be 0, because two force member will have at its end only force along the member, right? So it will be like this, right? And then you have all these forces, and forces. So if this is the case, then what you have is just equation of equilibrium of summation of Fx equal to 0, summation of Fy equal to 0, and summation of moment equal to 0. You have three equations, three unknown, you can solve, right? For example, as an illustration of what will happen, right? Normally, the easiest one is, because this is point E, right? This is point E. Let's say this is EX, EY, AY. This is point E, right? So if you do summation of moment, the easiest one is just take about this point, about point E equal to 0. And then if you take counterclockwise as positive, for example, so these two will not have any moment about this point E, obviously, right? This AY will have a moment but clockwise, right? So you have AY times a certain distance, which is this distance here, right? I do not know what is the value, but you just plug in. And then this one will produce a clockwise moment, counterclockwise moment. So okay, this is negative because it's clockwise. So this one is F1, right? F1, F2, F3. So plus F1 times the distance of this one from this one, okay? And then this one is counterclockwise also. So plus F2 with the distance of this one. Then this one counterclockwise also, plus F3 with the distance of this one, should be equal to 0. And because that's the 1, 2, 3 force. For 1, 2, 3, 4 forces that produce moment about point E. So from here, because these are all value that you know the value, so you can get AY equal to something, right? After you get that, then you can solve for EY, right? When you do summation of force in Y equal to 0, then you have AY, which is already known, plus EY, which you want to find, and then minus F1 equal to 0, because F1 is given. So you get EY, you know already also, right? And then for EX, actually it's straightforward also. If you do summation of Fx equal to 0, you'll have EX minus F2 minus F3 equal to 0, which all the value is given. So EX, you can know that also, right? So the first thing first is you understand the question, what is given. Draw the free body diagram, but in this case you have to understand what kind of free body diagram that you need to draw. In this case, it's just the whole thing with the just support reaction there and there. But of course, again, it depends on your understanding also on the true to false member in this case, right? Because this actually combine two understanding. One is trust, frames. One is two false member, right? So normally, this one you have to have a step in terms of the exam. You have to state that this is two false member, hence you have y you have value x is 0, right? So that's how this comes about. If you never declare that understanding, then this can be wrong. This can be understood to be wrong because ax must be 0 for a certain reason. It cannot just suddenly you just copy from someone. There's nothing there. We do not know whether you understand or you are lucky or you copy, right? So anyway, so that is the question that I can see from what is being messaged. There's something here as well, but I do not know. I don't think, because I cannot see the full diagram and what is the question. Well, the question is here, determine the horizontal and vertical force, but the diagram I cannot see, so never mind. But I think that you get the concept and how to calculate already, inshallah. So that's my input for how to solve all the questions that you have given. If I'm assuming the one that's watching this is the one who is giving me the question, and hopefully it helps. Inshallah, that's all that I can share. Hopefully it helps, and thank you very much. Subhanakallahumma wa bihamdika, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.